Under 3.4, we are expected to understand trigonometric identities, and we are supposed to know which identity is equals to what. And to start with, in part A, example 9, we are supposed to show or to prove that 1 plus the tangent squared of x is equals to the sec squared of x. But I want us to remember one major identity, which is the primary of all this, that the sine squared x plus the cosine squared x is equals to 1. Another one is that the sine of x over the cosine of x give us the tangent of x. These two are very important and critical in proving any identity. And to start with, in part A, you can see that we have 1 plus the tangent square of x, which is supposed to be equals to the sec squared of x. And we know very well, that for the sec squared x to exist, we must be having 1 over the cosine of x. And if you look at this, 1 over the cosine of x, so if we can use the very primary trigonometric identity, which is the sine squared x plus the sine squared plus the cosine squared x is equals to 1, using this, we can have the sine squared of x plus the cosine squared of x is equals to 1. So if we wanted to get the sec squared of x on the right hand side, that means we must divide 1 by the cosine squared x. And that means if we divide it by the cosine squared x, we will get the sec squared x. But the division of by the cosine squared x should not just happen on one term. It should happen all the time, at least to avoid changing the original value of our expression. So everything divided by the cosine squared of x. Interestingly, sine squared of x over the cosine squared of x, that one, using the second rule, that one gives us the tangent squared of x plus cosine squared over cosine squared 1 is equals to the sec squared of x. And this simply proves our first identity, which is 1 plus the tangent squared of x is exactly equals to the sec squared of x. Hence shown. It is part B that we must look at very keenly. Part B requires, again, we use the very primary identity, which is the sine squared of x plus the cosine squared of x, giving us 1. You can see here we have cosec. Cosec means we divide everything by the sine. So this gives us, if we divide everything by the sine squared of x, we just don't have to divide one term. It has to happen in all the terms. So even this one, divide by the sine squared of x. The sine squared of x. The first term gives us a 1, which is very critical. If you look at the second term, the cosine squared of the sine squared should give us it should give us 1 over tan squared of x. Because remember, if we talked about sine x over cosine x is the tan. So if we reciprocate this, the cosine of x over the sine of x should give us 1 over the tangent of x. So when all of them are squared, then this gives us 1 over the tangent of the tangent square of x, which is, if you look at it, it will give us 1 over the sine square of x. But we know we can rewrite these two in the secondary trigonometric ratios. 1 plus, this is 1 over tangent is cot squared of x, which is that is now the proof in part B that 1 plus cot square of x is exactly equals to the cosec squared of x. All right.